In this section of Lesson 1-3, we're going to find the midpoint of a segment. The midpoint of a segment is the point halfway between the endpoints of the segment. If x is the midpoint of segment AB, then the measure of AX is equal to the measure of XB. More formally, the midpoint M of segment PQ is the point between P and Q such that PM is equal in measure to MQ. And once again, our formulas are a little bit different if they're on the number line or if they're just anywhere on the coordinate plane. On the number line, all we have to do is average the two numbers. So add the coordinate for A and the coordinate for B and divide by 2. The coordinates on a number line of J and K are negative 12 and 16 respectively. Find the coordinate of the midpoint of segment JK. So I'm going to use M for midpoint. So it doesn't matter which is which, because we're adding, but negative 12 plus 16 is 4 divided by 2 is 2. So the midpoint is 2. Now it gets more interesting when we go out into the coordinate plane. The coordinates of the midpoint of a segment whose endpoints have coordinates at x sub 1, y sub 1, and x sub 2, y sub 2 are x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. So we're averaging the x part of the coordinate and averaging the y part. So find the coordinates M of the midpoint of segment GH, where G is at 8, negative 6. I'm going to call it x sub 1, y sub 1. And H is at negative 14, 12. I'm going to call it x sub 2 and y sub 2. So using the formula, we're going to add our x's. 8 plus negative 14 divided by 2, and add our y's. So negative 6 plus 12 divided by 2. And all we have left to do is simplify it. 8 plus negative 14 is negative 6. Negative 6 plus 12 is 6. So when we finish simplifying, we're going to get negative 3, positive 3. Average the x's, average the y's. Now it gets a little bit more interesting here. They ask us to find the coordinates of D if E is the midpoint of segment DF and F has the coordinates negative 5, negative 3. We're going to break our formula into two little equations. So I wrote M from our general formula, but in this case we have E. So I know the negative 6 is what I'm going to get, and I've got x sub 1 plus negative 5 I know. And I'm going to write down my y equation as well. So that's going to equal 4. And the y that I know is negative 3. So these are going to solve the exact same way. We're going to multiply both sides by 2. And we have x sub 1 plus negative 5. And then add 5 to both sides of the equation. So we have negative 7 plus x sub 1, or equals x sub 1. Same process over here, multiply by 2. So we have 8 equals y sub 1 plus negative 3. That times 2 divided by 2 just cancel out. We don't have to distribute it to the numerator. And then add 3 to both sides of the equation. And we have 11 equals y sub 1. So our ordered pair is going to be negative 7, 11. So a nice little review of some algebra skills. What is the measure of segment PR if Q is the midpoint of segment PR? Midpoint means middle, so if one side is 6 minus 3x, the other side must be the same, and it's also 6 minus 3x. So I can make a little equation. We're going to have 6 minus 3x plus 6 minus 3x equals 14x plus 2. So combining like terms, 6 plus 6 is 12. Negative 3x plus negative 3x is negative 6x. How we keep our algebra skills sharp. Going to get x on one side, so add 6x to both sides of the equation. So the x is dropped out there, and we have 12 equals 14x plus 6x is 20x, and then just copy down our plus 2. Subtract 2 from both sides of the equation, we have 10 equals 20x. Divide by 20, and we get x equals 1/2. Now, someone is going to pick choice A as the answer because we have 1/2. But the question asks, what is the measure of segment PR? So to finish the question, we need to substitute in 1/2 for the x. So 1/2 of 14 is 7, plus 2 is 9, which happily is one of my choices. Any segment, line, or plane that intersects a segment at its midpoint is called a segment bisector. In the figure at the right, M is the midpoint of segment AB. In plane N, segment BD, line RM, and point M are all bisectors of segment AB. We say that they bisect segment AB. You can construct lines that bisect a segment without measuring to find the midpoint of the given segment. And once again, we'll do a little paper and pencil exploration, but mostly we'll let the computer do our constructions. Now they showed 4 different segment bisectors, but there could be an infinite number of segment bisectors, and each must contain the midpoint of the segment. Distances can be determined on a number line or the coordinate plane by using the distance formulas. We did that one, and then this one was the midpoint of a segment is the point halfway between the segment's endpoints.